Okay, good day everyone. Welcome to Marina's Powerhouse team. My name is Engineer Reggie Marina. You can call me Kuya Reg for short in our country in the Philippines. But I believe there are non-Filipino students who are watching us, no? Because we're going to upload this in our YouTube channel. So we will continue our lesson for today about the series RLAC circuit. Let's go with the part 2. Okay. Let's solve this problem number 5. Okay, find the impedance of the circuit which requires 1,540 bars. So what is a bar? Okay, voltage of 230 volts and a current of 10 amperes. So here we are going to consider the power triangle. Let us draw the power triangle. Okay, so this is the power triangle. This is our S, P, and the Q is our angle theta. Okay, so find the impedance of the circuit which requires power. Okay, so we are given the reactive power Q that is 1,540 bars. Okay, so we are given the voltage and the current. Okay, basically that is our S, right? So that's equal to the voltage times the current. Okay, so what is the voltage? The voltage is 230 volts times current 10. So we have here 2300 or 2300 volt amperes. Okay. So we are asked to find here the value of the impedance. Okay. What is the impedance? The impedance simply equal to, let's say, all of these are just the magnitude, okay, the S, the V, and the I. Also, the Q here, the P, then we have here our S. Let's say, let us refer for the dimension of the triangle here. We have the absolute value. So, let's say you have your absolute value for Z. By Ohm's law, this is equal to the voltage over the current. Okay? Over the current. Sir, I have a question. If the voltage is, if we have a given voltage, what is that value? Okay? It was not specified as maximum, average, or RMS. Well, it is automatically RMS value. Remember that. Especially if you're dealing with 220 to 30 volts, no? That is the RMS value if you have your multi-tester or a voltmeter, AC voltmeter. You're going to measure the voltage in our outlet. Let's say that is approximately 230 volts, and that is an RMS value. Always remember that AC meters measures RMS value, RMS or the root mean square. Okay? Or that is what we call the effective value. Effective value. Okay? The DC meters, if you have a direct current meters, DC voltmeter, DC ammeter, you're measuring the average value. So please take note of that. Again, AC meters measures RMS value. DC meters measures average value. No? Pag AC meter, RMS value. Pag DC meter, average value ang sinusukat mo. Okay. So, let us have here. What is our RMS voltage? 230 volts. So we have here 10 amperes. Of course, we just have here 23 ohms. But take note, in our choices, that is in rectangular form. So we have to know the angle. How to get the angle? How to know the angle? Here. Okay, so we already have our S. What trigonometric function, no, that can be used, no, for us to solve the theta here? We are given the Q, we are given the S. I think it's sine theta, right? So that is SOHCAHTOA. So sine theta, SOHCAHTOA, so that is opposite over hypotenuse, isn't it? So we have here, what is the opposite here? The opposite is our Q. Okay? The hypotenuse, this is the opposite. The Q, take note, that is the opposite. Opposite. Okay? The P is what we call the adjacent side of the triangle. The S, of course, is what we call the hypotenuse. Okay? So sine theta, that is the opposite over hypotenuse. The opposite is Q over the hypotenuse S. So we have here our S. Okay? And then we can now solve, basically we can solve directly our theta. That will be our arc sine of, okay, still you have your Q, that is 1,540. Our S is 2,300. There you are. What will be our theta? Okay, what is our theta? Okay, let us solve this one. Arc sine of 1,540 and divided by 2,300. So that is equal to 42.03 degrees. 42.03 degrees. So therefore, we can have our Z. The polar form is 23, then bar angle of, okay, since this is inductive, that should be positive. No? So we have here 42.03 degrees. So let us convert this. Now, did you remember our topic before about the complex number? Okay, so this is the continuation. Okay, but if we have, let's say, a first timer or a newbie, no, we call this as a newbie, right? So you can watch my YouTube channel, no? So the Reggie Marina YouTube channel. So there is a playlist there. The playlist of this particular topic is the Restudy EE. Okay, go to my playlist and you will see those topic about electrical engineering. Okay, so we have shift. You press the minus sign now. So we have the 23, then the shift, close parentheses, so you will have your comma. So you will have here 42.03. Then okay, so we have here 17.08 plus J. Your J is your Y part here. That is your 15.4. 15.4 ohms. So that will be our final answer for this problem. And that will be letter, let's go here, letter E. Okay? It's our answer for number 5. Okay, let's go now to problem number 6. Problem number 6, a coil with a resistance is placed in series with non-inductive resistance of 3 ohms. When a voltage of 104 volts is applied to the circuit, the voltage across the coil is 66 volts, and that across the resistor 50 volts. So calculate the power factor of the coil. So let us draw our circuit first. So drawing muna natin. Let's draw this circuit. So we have a given coil here. Then we have a non-inductive resistance. So meaning it is a pure R here. Okay? It's a pure R. A coil with the resistance in place with a non-inductive resistance. So we are given here a 3 ohms. Then we're given here a this is 50 volts. No? Given here 50 volts. The voltage here. So we say we have a voltage here. Let's call this as VR. 50 volts here. Okay. So the voltage across the coil is 66 volts. So this is the coil. Shall we say this is the R of the coil and this is X of the coil. Okay. So we have 66 volts. Let's say we have a voltmeter here, 66 volts measured on the coil. Okay. Yeah. So we're asked to find the power factor of the coil. Okay. So we have the total. No? Let's have the total voltage. This is our total voltage, by the way. Okay. So the total voltage squared, that's equal to the VR total squared plus VL total. Then you have to square it. So this is a formula for a series RL circuit. For a series RL. So we have the total voltage squared, that's equal to, what is our VR total here? Our VR total. Our VR total would be the VR of the coil, okay, and then plus the VR of the pure R, that is quantity squared, then plus. So we have here our VL, the total voltage at the inductor. Okay. Since there is no coil here, in our resistance here, there's no series resistance because it is non-inductive resistance. So the only voltage at the inductive portion is the voltage at the coil here, at the X of the coil. What do I mean? So this is just the voltage at X of the coil. Okay? Then we have to square it. There you are. Okay? This will be our working formula. Okay? And then, let us have the V total of the coil So that is equal to VR of the coil. Okay, that should be squared plus BL of the coil. That should be squared. Now, the V total of the coil is given to be 66 volts. That should be squared. 66 squared, that is equal to VR of the coil. Well, that is unknown here. Squared, then plus the BL of the coil. That should be squared. Now, we have here the BL of the coil. Let us get the BL of the coil. That's equal to 66 squared plus, oh, by the way, what will happen here? This is the BL of the coil that should be squared. That is equal to 66 squared. Then let us transpose this. This will become VR of the coil squared. Okay. Oh, by the way, this should be minus. Okay, that should be minus. Okay. So we are going to substitute this. No? This is the X of the coil. Okay. So we have here, okay, we have here our B total. We have our B total here. Let's double check. So yung B total natin, we're given the B total, right? Yes, that is 104. So it is 104 volts. 104 volts. The B total. So let us substitute now. So we have here our B total 104 squared. We will make use of our working formula here. Okay? Kunin natin to. Ito yung working formula natin. Okay, so we have here what is BR of the coil? So let it be BR of the coil. Okay, and then plus, what is BR? Simply 50, that's given, squared. And then plus, what is BX of the coil? Actually, this is the BL of the coil. They mean the same. So we have here 66 squared minus BR of the coil. You will see here, that should be squared. Okay? There's only one unknown here, which is the VR of the coil. Let us solve that. Let us solve the VR of the coil. You will see here 104 plus input 104 x squared and alpha cut. So we have here our BR. Let's make it as variable x, alpha close parentheses, plus 50 close parentheses. You just press x squared so that you will have here the square. Then we have plus, open parentheses, we have 66 squared. Then minus, alpha close parentheses, that should be squared, close parentheses, then shift calc equals. The VR of the coil is 39.6. 39.6. So we are to get the power factor of the coil. That is simply equal to VR of the coil, okay? VR of the coil divided by the V total of the coil. So you will come up with 39.6 then divided by 66. So that will be our answer. So 39.6 then divided by 66. So the answer is 0.6. That will be our power factor. Okay? That is our power factor. Okay? So you may copy that solution. Okay? And put your okay? So para makopya muna nila o ma-screenshot nila yung ating mga solution dyan, mga kawerpa. Okay? Then we'll go now to problem number 7. Okay, let's go now to problem number 7. Problem number 7. So I may draw the given here. Okay, so you can go here. Show this portion. When a DC voltage of 30 volts. Anyway, so let us have first this one. When a DC voltage of 30 volts is applied to a given coil, the power consumed is 150 watts. When an AC voltage of 230 volts RMS is applied to the same coil, the power consumed is 3,174 watts. Find the reactance of the coil. So what will be the reactance of the coil? Okay, so we have here our first, the coil is connected with DC source. It's connected to DC source. How much? And a DC voltage of 30 volts. So we have here 30 volts. Okay. Of course, our coil, it has R and it has X sub L. No? X sub L. Okay. The power consumed is 150 watts, meaning that is our power in DC. That is equal to 150 watts. 150 watts. Okay? When an AC voltage, 230 volts. So we have an AC voltage here. Okay. So our AC voltage, 230 volts, RMS. Is applied to the same coil, the power consumed. Okay, so we have here power in AC, so we have 3174. Is 3174 watts. Well, of course, still our R and our X sub L. Remember, the PDC, or what we call that 150, is equal to V squared over R. Remember that power is V squared over R. So, what is our V? 30 squared. Then over R. So, therefore, our R will be equal to, let's calculate this, 30 x squared, then it should be divided by 150. Let us have interchange the position here. So we have 150. So the answer would be 6 ohms. And remember that 6 ohms is also the resistance here when you connect it in the AC supply. So we have 6 ohms. And we have said that only resistive elements consumes the watts. So this is our I squared. We have this formula, I, R, and S squared, okay, times R. Okay. Now, let us get here our I. Okay, remember, our R is equal to 6. So we can shift solve this one. We have 3174 alpha calc. So we have alpha close parenthesis x squared. Then we have to multiply it by 6. Shift calc equals. So the answer would be 23. The current is 23 amperes. The I here will be equal to 23 amperes. So what is the unknown in the problem? Find the reactance of the coil. Basically, our X sub L is the unknown. So let us have our impedance. So by Ohm's law, we have 230, okay? Then divided by 230 volts. This is 230 volts. Then divided by 23 amperes. So you will have here 10 ohms. So you have here 10 ohms by magnitude form. So we can have an impedance Z here. We have an impedance Z. So by magnitude, so we'll be having Z squared. That is equal to R squared, then plus X sub L squared. Let us substitute here. So we have here 10 squared. That's equal to 6 squared plus X sub L squared. So our answer here will be 8 ohms. Our X sub L will be equal to 8 ohms. And that will be letter, okay? The answer will be letter B. Okay? Letter B. That is our answer. Okay? Okay, you may copy our solution. Okay, so may copy that. That one. So, pakopya natin, partner. Okay, so our answer for number 7, no? Number 7 is letter B. Okay, so well, that's it for today, no? But before we end our discussion, let let me share this. This is what we call the verse of the day, or this is energizer actually of the day. No? We call this as energizer of the day. So found in Ecclesiastes 9:30. So first in our language in Filipino. So nakita ko rin ang karunungan sa ilalim ng araw sa ganitong anyo at naging tila dakila sa akin. This wisdom have I seen also under the sun, and it seemed great unto me. Okay, well, thanks be to God mga kawerpa, and to all our friends watching. Thank you for watching us, but we're not yet finished, no? We have to read some social media comments. Okay, Terbs Daroy Magbanwa, you can scare me because I'm proud. RME reviewee of NPHT Review and Training Center and mentored by Kuya Reg. It's a great blessing during the pandemic time wherein I cross paths with Kuya Reg and his free webinars, which changed a part of my life in a very positive way. A positive outlook in life. Go for glory. Glory be to God. Prince Locaberte, maraming salamat po sa patuloy na pagbibigay ng libreng kaalaman. Sad to say na di ako nakasubaybay ang ibang programa mo dahil sa trabaho. Pero buti na lang may YouTube channel po kayo. Maraming salamat po ulit and thanks be to God. John L. Tipay, thank you again. Meron na naman akong nakuhang answer formula dahil po dito sa mentoring program na ito. Marami tayong kaalaman na ito. Sana patuloy. Thank you very much. Abelardo Abisamis, very informative po ang topics. Nice po. Sana madami pang ganitong service. Mabuhay po kayo. Sana gawin ng ibang review center yung ginagawa nyo. God bless po. Robin Andrew Salinas, sir, salamat po sa another free lecture, sir. Na-refresh po yung knowledge ko about the three-phase. If I remember, nung 4th year po namin inaral to and still retain pa din sa utak ko. Salamat po sa NPHT. More power to come and God bless din po. Ramon Carlos Hadlocon, thank you sa bagong electrical topic, Kuya Reg. God bless us all. Thanks be to God. Fred Bunyi, thanks be to God. Salamat po NPHT sa iyo, Kuya Reg, at sa staff. Sana po ay patuloy lang ang ganitong programa na malaking tulong sa aming mga electrical practitioner at sa ibang mga student pa lang. God bless po. Danny Dumagat, I highly appreciate your topic, sir. Madami po akong natututunan. John L. Tipait, I appreciate this kindness public service program and PHT and UNTV, a free webinar dahil po dito naging interesting na po ako mag-aral. Thank you very much. Roylan Salap, good morning po MPHT. It is indeed another day of great learning experience, more power. Yan po ang ating mga social media reactions, mga kawerpa. So tuloy-tuloy po ang ating pong mga free webinars